Alright, on this, on the starter, then we will go over some problems off the homework. And maybe, we got an hour. Riley is focused. You're lucky, Dave, because the person that normally sleeps isn't gonna blow this for all of you, right? So, if everybody's focused, we'll put the test off till Wednesday next week, because I was homecoming and everything. I'd rather not have it on Monday, because that's not gonna help any of you guys out, right? Normally, I wouldn't give a crap one way or the other. Normally, I wouldn't care one way or the other. And hopefully I wouldn't get on there with it. So, if you guys can stay focused, we'll go over stuff. And I know that there's some stuff, because I was looking over the Chapter 2 review, and we might not have covered a couple of things that I put on the test very well. So I want to go back over them to make sure, because I don't remember talking about them a whole lot. So it might have been something that, maybe one of those days where we were rushing right to the end and I skipped through something real quick. That's about every day, right? Yeah. On this, first thing you should do, I would make the list, very first thing. Just list out the numbers. So if we make the list, easiest way to make the list is off the stem and leaf plot. Now, what did I mess up on the stem and leaf plot that you better not mess up on the test? What didn't I put on there? Sorta. You need gotta have a key. Alright, so I should have put something like this on there, and maybe that would help Dom so that he didn't ask that question. What's why is there a slash between there? Yeah, I know. So 3/7 tells you what? 37. I should have put a key on there. When you, if they ask you to make a stem and leaf plot on the test, make sure you put a key on there so that we know this is 37 and not 3.7 or not 370 or some other number. Then we have 47, 53, 56. When there's nothing by the 6, what's that tell you? Nothing there, so we just skip over that. 74, 79, 79, 81, 84, and 100. Does that look like your guys' list? Count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's hard to believe I'd make it 10, trying to make it easy. So we got 10 is our n. We want to find the mean. What would we do with all these? Add them all up, divide by 10. Median, we do what? Alright, you can mark out on both ends. I don't like doing that. If there's 10 of them, where's the middle going to be? The fifth one. Now you get 1, 2, 3, 4, 5. Is that the median? No. Is this one the median? It's in between. So we'd have to add those two and then divide by 2 for the median. For the mode, which one's the mode?
79.
So we could just write that down. Mode is 79. And then for standard deviation, we'd have to do that big chart, right? No other way around it. You'd have to do the big chart. But the reason I'm skipping over a bunch of this is because I don't want to do any of that. I want to use my calculator. On the test, if I don't ask you to make the chart, which there are a couple of problems where you're going to have to make that chart with the classes and everything else, but use your calculators. And again, I'm going to go through this, how to do it. You hit stat. If you wanted to follow along, you could punch it into your calculator. It might be a good idea to make sure you understand it. Hit stat. Go to edit. I'm going to put mine in list 1. Probably not. My batteries just went dead. it'd be a good idea. Dom's he's using my tablet there, he's gonna grab it and hit calculator on it and punch it in. Jacob's not gonna sit there with his hand on his mouth, just looking at me like he's trying to act like he's intelligent or something. He's gonna actually punch it into the calculator so he can understand it. Stat, just hit enter, go to edit. I'm gonna put it in list 1, 37, enter, 47, enter.
You lost me. Where's stat?
Stats right up next to the arrow button.
You haven't said calculator. Yeah, I
Just go down.
Yeah.
Down or enter, either
But
one.
is
It's
this
the same
one-
thing.
The stat plot.
No, just stat. It's right there.
How do I get over this?
Quit pushing it.
You hit edit or what?
Let's go back.
What is this stuff? There's already stuff in
So we'll get rid of it when we put in these other numbers. Everybody with me now?
here.
Stat. S-T. I'm not supposed to be sarcastic, sorry. Stat. First one says edit. So all you gotta do is hit enter. Everybody with me to that point?
You lost me.
Now we're just gonna punch in the numbers. I'm gonna put mine in list 1. If Dom's confused because there's already numbers in list 1, could he go over to list 6 and put them in? Yeah, go right ahead. And if you're doing a homework and you know you got numbers in a list and you might want to keep them there for whatever reason, put it in a different list then. But I'm going to put it in list 1.
How do you delete the numbers out of the?
Well, hold on. Let's put these in first, because as you put these in, it'll delete the one that was there already. All right, so I just punch in 37, hit enter, or Grant said you could just hit down, the down arrow, does the same thing. 47, down arrow, 53, down arrow, 56, down arrow, 74, down arrow, 79, down arrow, 79 again, down arrow, 81, 84, and 100. Now I still got more numbers in my list after that, all right, because I had some bigger, longer list on there. So I can just go through there and I hit delete,
Yeah, you can't put a zero.
delete, delete. All you do is hit delete, and it'll keep deleting all the way down the list, and keep deleting until you get down to a blank. See, I think I had like 20 numbers on here or something. So, all right, now I'm down to a blank. There's nothing in that space, so I don't have to delete anymore. And I just have my list of 10 numbers on there. Everybody with me to that point?
Yes.
Now, we need to find, we already found the mode. We need to find the mean, median, what else did they ask us to find? Standard deviation, all right? Mean, median, standard deviation. All you have to do is hit stat again, go over to calculate this time. We don't want edit this time, we want calculate. And when it pops up calculate, it's got 1 variable, 2 variable, linear regression, quad regression, cubic regression, so on, so on, so on, all the way down through there. Some of that stuff we'll get to later on in the year. Right now, all we're doing is 1 variable. So just hit enter, and on your screen it pops up 1 variable stats. Just hit enter. Now see how it popped up? So you got 1 variable stats. Yeah, that's because you hit something else first. So let's go back, let's clear that. Now go back into stat. Go over to calculate, hit enter. Now it just says 1 variable. So you just already had the sort up there on your screen. Alright, so what you're telling the calculator to do is find all the statistics for this 1 variable, our 1 variable, our x right here, whatever it is.
Is that
Right.
SX? That's the standard deviation.
We'll get, don't get ahead of us, Jesse. You know what happens if you get ahead, then somebody else gets behind, and then we're all on different spots, and then Mr. Eversole's getting. So we go one variable stats. If you put it in list one, you look for the blue where it says L1, L2, L3. We want list one, so we hit second, then the L1 button, which is the number one button. So you hit second, then the L1 button.
Do we need a frequency list?
We will on the test, but not for this one. We got this. What's the X bar tell us? X bar is the mean. So what's the mean?
69.
69. We also need the median. Does this tell us the median anywhere? Yeah, if you scroll on down, it'll tell you the median.
76.5.
76.5. And then if we go back up, we got the sum of all of them. If we need that, the one right under X bar, the sum of all the X's was 690. So these all added up to 690. Then the next thing is all the X's squared. We haven't done that yet. The standard deviation, if it's a sample, is 19.68 something, right? If it was a population, the standard deviation is 18.67. Remember with standard deviation, if it's a population, you got n on the bottom. If it's a sample, you got n minus 1 on the bottom. That's why they're different. Probably I would accept either one of those because I don't think on the sheet it didn't tell you whether it was a sample or population, so I'd probably accept either standard deviation. So you could have used either formula. Then it says n is 10. Well, we already knew that n was 10. Oops. Hang on.
I don't see median.
You don't see median? Why doesn't he see median?
This is X bar.
No, I mean like
No,
mine.
you gotta go
I
back
don't
in.
have my X bar over here. I don't have 76.5.
I know. So why doesn't he see median? What's he got to do? He's got to scroll down.
There's no way it is the median. So you're not messing with
It's because you're pressing buttons just at random.
really.
I actually hit a button, I had to redo it.
You hit like 65 buttons. I sit here sitting to watch you doing this, and then wonder why it's gonna mess up.
You're just not
you're-
up to date.
You're like my wife on the computer.
It's like my dad.
How come this isn't working? Well, you pushed the button 600 times, and now it's trying to get caught up to with where you're at.
It should work sarcastic. It should work as fast as I should work. Everything is self-log out.
So 76.5 is the median. If you go on down, what's Q1 stand for? This was on your homework. Quartile 1, so 53. Q3 is quartile 3, which is 81, so that's splitting it up. So they're saying
Bam.
this is quartile 1, this is quartile 3. Got to be able to do that. And then the median was right in there. So, and that's quartile 2, right? Quartile 2 and the median, same thing.
And then you just put a box and.
Yeah, but they already had the box and whisker for you on this one, right? You were going backwards, going the other way. Now, on the bottom thing, decide whether the data fits the empirical data. If I do this, and you're going to have to be able to draw this on the test, what goes right there in the middle? Actually, the mean, right? 76, or 69, sorry. 69 goes right in the middle. And then all we're gonna do is take some numbers on either side of it. We know that the standard deviation, let's say the standard deviation, we'll just go with the sample and we'll say it's 19.7. That's almost 20, right? So if it's almost 20, we go one standard deviation below, what's this next number gonna be? 49. What's the next number gonna be? 29. What's the next number gonna be? Does everybody see that, how I did that? Because that's important. You got to know how to do that.
I use my good out.
All right, yeah, if you use the 19.6, that's fine. I'm just being lazy and don't feel like.
Now, how'd you get it?
No.
What did you do to get that?
This is the standard deviation. This was our S, 19.7. I rounded it off to 20, just being lazy. And then I said, all right, this is our mean. One standard deviation below that means we subtract off
You can subtract 20 every time.
20
And then
every
you're
time.
subtracting zero.
Now going the other way, we get what? 89, 109, 129. How come I don't go higher than 3? All right, everything should fall within 3 standard deviations one way or the other, right? So we're trying to say, in between these two, what percent of the data should fall in there? 68%. So let's look back up here. In between 49 and 89. 49 and 89. We got 1, 2, 3, 4, 5, 6, 7. 7 out of how many? What is that as a percentage? 70%. Is that pretty close? Yeah, it's pretty close. How much should fall from here to here? 95%. So that's 29 to 109. 29 to 109. That's 100%, isn't it?
The next is 97, right? Or
Now, the next one would be 97.5%. Well, we already got 100%. Do we really have to calculate it?
Of course.
So does it fit the empirical? Does about 68% fall right there in the middle?
Yeah.
And then 100% or 95% fall within? Yeah, it sort of fits. It's not a real good fit because it probably looks more, if we were gonna graph it using the bell, it looks more like that, where it fits in there a little tighter than it should for the bell curve. Alright? So that sort of makes sense. You gotta be able to do all that stuff on this test next week.
Yes, sir.
Alright, open up your books to, what was the homework page?
107.
Page 107, open up your books, question.
Got me one.
First test wasn't real difficult. This test's gonna be a whole lot harder. So you better pay a lot of attention today. Dalton, did you just hear all that?
Something about something.
Said, we're gonna get ready to take the test here in a minute.
Alright.
Cause you guys were there talking too much and getting on my nerves and I didn't really go sit down and do nothing.
I was supposed to ask you about the homework.
I'm gonna take it.
What are you asking me about then?
Well, no, it's just.
Don't say no, see, don't lie and then
I
get
got
caught.
it right.
Don't lie and then get caught in it and then.
No, I'm being for we was talking about the homework.
We really was.
Questions, problems you wanna see worked off page 107. None? Everybody understood all of it? Better ask. If you understood it all, then we should just take the test today.
Trying to find it, getting this
I
copy.
mean,
I did give you time and you were over there talking. Huh?
maybe I should take it before I leave.
That might be a good idea. Take it tomorrow.
I don't have intervention right now. I leave at like 10:19.
You get it?
I can take it. How long do you think it will take?
An hour.
Oh, so I can't take it right
Always kills me. I leave at 10:19. Now you guys gotta be at work that quick. I know you're not there all the time. And then, no, I can't stay extra. I can't stay an extra hour and get this done. I have to go to work. Yeah, you gotta be at work at like 3 o'clock or something
Well,
stupid.
I really can't stay extra,
No, I gotta
only
work.
because we're leaving after I get out.
But I bet if I called mom, she'd think, yeah, that hour would be spent all right. He could probably stay and do that.
I don't know.
Your dad don't make any decisions.
Yeah, right.
Dad don't make decisions. Mom makes decisions.
What's the hour?
Question.
My dad makes sense.
Questions on 107. Everybody understands quartiles, box and whiskers, all that stuff.
We do, yeah, what numbers
Do number 35.
35. Refer to the data set in exercise 31 and the box and whisker plot you drew that represents the data set. So that must mean we have to go back to 31 and draw a box and whisker plot, right? So, look at 31. Somebody help me out, all of you, because otherwise it'll get lost.
I've never learned 0 to 10.
All right, so we know, but how many numbers do we have there? How many numbers are in 31?
28.
28? So we got 28 of them.
Yeah.
Let's just do this real quick. Let's just make a frequency, just a little frequency distribution so that we can keep track of them all. We got, is there any zeros? Yeah, there's a 0 in there.
I got CBI convention next class, Mr. Ferguson will let me do it then.
That's my plan, and I ain't messing with it during my plan. Got better things to do.
We'll take it in this class.
I say, yeah, right.
I won't cheat, I swear.
That's the
0, 1, 2, 3, what's it go up to?
4, 5, 6, 7, 9.
9? 8, 9. Look through there, how many zeros we got? Just one? How many ones?
2.
Everybody agree with that?
Yeah.
How many twos?
6.
6. How many threes?
4.
4s? 5s?
4. Wait, 5. I missed one at the end.
5, is that right?
Yeah.
6s?
2.
7s?
2.
2? 8s? None? 9s? 1? 3, 4, 5, 10, 15, 25, 28, that's what we had, so that should be right. Now we want to make a box and whisker plot. Make a box and whisker plot, 0 to 10, or 0 to 9, whatever. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, for a box and whisker plot, you need your 5 numbers. So you need, we probably should have went ahead and put these in order. You need your 5 numbers. You need your highest, well, lowest,
They are in order.
highest. Yeah, we should have wrote them out in order.
They are.
But we should have went ahead so that we could count, because this is gonna make it harder. So Dalton, you'll have to watch closely, because the way I'm gonna do it,
Oh, I see
it's
what
gonna be a
you
little
mean.
different.
Alright.
Alright, highest, lowest, quartile 1, median, can't read that, quartile 3. We need those 5 things. So the lowest we know is 0, so we can put a dot right there at 0. The highest is 9, we can put a dot out here at 9. Now to get our 3 lines, we need the median, quartile 1, quartile 3, and that's gonna be a little harder on here, right? We got 28 numbers. Well, if you're given a chart like this, instead of the list out, divide that by 2, what's 28 divided by 2? 14, so we wanna go out to the 14th number. 1, 2, 3, 9, 10, 11, 12, 13, 14. So 14th number is gonna be 4 from this way. What's the 14th number gonna be from the other end? 4 also. So 4 is the median. So 4 is the median. So we're just gonna put a little line right here. How many numbers do we have down here? 10, right? What's half of 10? 5, so we wanna go 5. 1, 2, 3, 4, 5. If we go this way, well, we're gonna end up right in the middle, so what's that gonna end up being? What's between 5 and 6?
Or 5.5.
5.5. So our third quartile is gonna be 5.5. This would have been easier if we'd made the list out completely, right? But we can still do it this way. Put a line right there, 5.5. We do the same thing up here. How many numbers we got above here? 10. Now there's, did we do something wrong? 13.
Our 14th number was 4.
That's right, we had a bunch of 4s, didn't we? So we probably should have made this list out.
Yeah.
Because it's gonna be,
Well, our 14th number was our first 4.
first 4?
The first 4 and the 13th number.
So that means we still got 4 others down this way, right?
Yeah.
So we should have used those. So we should have made it out, it made it a whole lot easier. So what do we got here? 10, 13, 14th number is 4. So the 4 is the 14th. And then after that, we want the rest of them to be down this way. Well, the 14th and the 15th, we need both of them, don't we? Because we had to split them in half. So you had 13 numbers this way, 13 numbers this way. So let's go back up this way, 13 numbers. We want we want half of 13, which is 6, 6.5. So 3,
That's a 2.
it's gonna be on 2. So that's the first quartile. Let's do the other end again just to make sure, because 5.5 is probably wrong.
That confusing.
Yeah, so what's gonna be easier? Write the whole list out in order, right? That way you don't have this confusion, because then you can look at it. If we go up this way, we got
It's just 5.
10, it's just 5. You got it on the calculator, so it's just 5. So this right here is not supposed to be there. Now what do we do with that?
Boxes in.
Box it in, draw the whiskers out here.
Put check mark and go.
Now you guys asked me to do problem 35. About 70%, 75% of the people watch no more than how many hours of television per day? What's this whisker? What percentage does this stand for? 25. This one stands for 25. The box here stands for 50. What's that called again?
Box. Oh.
Interquartile range. Good. Interquartile range. Interquartile range. About 75% of the people watch no more than how many hours of television per day? Well, where would 75% fall out on here?
At the first quartile on the box. Or even.
Here?
You said 75?
No, other side.
That would be 5.
Well-
So that would be, A would be 5, right? Because it'd be it'd be right here, the quartile 3. Because 75% less, 75% of the people fall down this way. Part B, what percent of the people watch more than 4 hours of television? So from here over, what percent? 50%. 50%. And part C, if you randomly select a person from the sample, what is the likelihood that the person watched less than 2 hours of television?
25%.
we got less than 2 hours, be careful. Got less than 2 hours, and you're right, it should be 25% is what it looks like by the box and whisker, right? So let's look back up here and make sure. Less than 2 hours, well, how many people were less than 2 hours? 3 out of a total of 28. Somebody divide that on their calculator and change it to a percent for me.
0.1.
So that means about 10%. Is that what it was?
0.107.
So maybe 11%. Because if we got 0.107, we want to change that to a percent. What do you do? Bump it over 2 places, then we could round up and get about 11%. Other questions? Got others, or are you just gonna find one just so I can do it? 'Cause otherwise we'll go on, because we probably should go on anyway. Alright, on these notes, you probably want to write this down. This is what you have to know on this test. Be a good idea to write some of this down. I'll try to point out what's going to be important to write down for the chapter 2 test. This thing, you're probably not going to draw these graphs, and I understand that. You might want to make it just to make sure that you remember what they are. Got to be able to make a frequency distribution and a histogram. Got to be able to make those two. Frequency distribution is this right here. Could it have a whole lot more than that in it? Yeah, this one here has got just the intervals, the class frequency, so we could have all the other stuff in there also. And then the histogram, remember the histogram is this. Maybe.
Got it.
Don't forget with stuff like the histogram, what's that tell you?
0 to skip one.
It's skipping a bunch. Alright, skipping a bunch. And with the histogram, what has to be true about the bars? They gotta touch each other. Looking at this one, because this is something that we'll talk about here in a few minutes. What's this, what shape does this have? Symmetric, alright, sort of symmetric there. Looks like we could split it up and it sort of looks the same on both sides, right? Remember you got skewed right, skewed left, and symmetric. With your frequency distribution, why this one? I have no idea why the midpoint's clear over here and the tally's over here in the frequency. We switched those around and midpoint was way over there. Other things you're going to have on there, remember you're going to, if you have the classes, you have it one way, you might you probably need the midpoint, but you're also going to have like x minus x bar so that we can figure out some of the stuff, then x minus x bar squared and all that stuff. So be able to make the tables even if it's got more than that. We talked a little bit about class boundaries. Class boundaries, remember, for if it was 50 to 54, we just went down a half unit this way and up a half unit on the top side. So it'd be 49.5 to 54.5. I'll make that harder than it is. Make sure you can find the class width, class boundaries, class limits, the range. What's this symbol mean? Sum. Relative frequency. Relative frequency is the percent that certain thing occurs. So you might want to put percent next to that. Cumulative frequency. Remember the cumulative frequency is just all of them added up to that point. Ogive. Be able to make an ogive. And be able to make a frequency polygon. We didn't do a whole lot with frequency polygons. Frequency polygon just said if we had our numbers here 1, 2, 3, 4, 5, and how often the frequency over here on the side. 0 might have happened no times, there wasn't no zeros on our list, then 1 happened 5 times, 2 happened twice, 3 happened 3 times, 4 happened once, 5 happened 7 times, and then 6 out here wasn't on our list, so it happened 0 times. And then to make that polygon, you just connect all those, and then it encloses the figure. That's a frequency polygon. Remember the ogive? The ogive starts here and says, okay, this happened no times, this one happened once, then we're a total of 3, then a total of 4, then a total of 5, total of 6, total of 7, total of 8, total of 9, whatever. And when we get up here, what percentage should we be at? 100%. It's just showing that, hey, we added them all up to get to that. And that's, the ogive is the part that you use the cumulative frequency on. Relative frequencies just for non-math people, so that Nick can tell whoever's looking at this, hey, 32% of the people had 6 as their answer. Be able to make stem and leaf plots. Dom wasn't here for this, so he's going to make sure that he knows this. Please make sure you put a key on it. Unlike me, you can take a point off of my paper that I handed out to you earlier on my grade because I didn't put a key on it like I should have.
You can get us there.
Give you an extra point, all right?
Yep.
So make sure you put a key on it. This one, what's special about this one?
It's double.
It's a double, it's a back-to-back. So tell me what that stands for. 120. Tell me what that 15 and that 5 right there stand for. 155. You didn't understand that that meant 120?
Is that a 0 over there?
Yeah,
Yeah, I got it.
Oh, okay.
it's just backwards.
Yeah. So,
So
what was the bottom one then?
155.
Oh, so either way, it's still.
Yeah.
Alright, yeah, that's.
So what do you think this stem and leaf plot was doing? Comparing what?
Chips.
Potato chips to tortilla chips. Probably sales of one compared to the other.
Yeah.
And be able to do that, you got to be able to look at what the data is and say, okay, what am I thinking of this? And I'm sorry, it's not sales. What is it? I should look down here.
Calories.
Calories in each one. The different kinds and how many calories are in each one. Yeah, I shouldn't. Be able to make and use a dot plot. I was just looking at the test a little while ago, and I know there's a dot plot on there. We didn't talk a whole lot about a dot plot because they're not very difficult. Yeah. So make sure you know how to use a dot plot. Guarantee there's one on the test. Does everybody understand the dot plot?
Yeah.
Tell me the list of numbers that made this dot plot.
0, 0.
0, 0, 1,
2, 2, 2, 2, 2.
How many?
Another one.
3
3 1s,
5 2s.
5 2s,
3 3s, 2 4s.
3 3s, 2 4s.
Yep.
30.
Pie chart. Be able to read a pie chart, deal with the pie chart. Remember a Pareto chart, what's different about a Pareto chart?
High to low.
It goes high to low all the time. It goes high to low. So a Pareto chart always goes high to low, and it's not going to have numbers. It's not going to have quantitative stuff on the bottom. It's going to be categories of some kind. Scatter plots, be able to do a scatter plot. Also be able to read a scatter plot. What if I put an X right here? Somebody tell me what that X stands for. About how many days?
84.
About 84 days, and what's the other part?
5.4, 5.3.
5.4, 5.3 weight, whatever. So 80 days, probably talking about weight loss or something. 80 days, person should lose about 5.3 pounds. Time series chart. Time series chart, what goes along the horizontal axis down there? Time. Months, years, days, hours, whatever it happens to be. Be able to find the mean. Remember, mu stands for mean. Add them all up, divide by how many of them there are. Be able to find the median, mode, weighted means. Find the mean of a frequency distribution. Remember, that's where we had to throw in the F. You should have all these formulas somewhere down in your notes somewhere. Notice it says over here for populations and samples. Everything I put up here, well, this one, what would this one be for, a population or a sample? Population, this one would be for a sample, sample. Bimodal. I don't think we talked a whole lot about bimodal. Somebody do me a favor and look up in their book, just in the back, real quick, grab your book and look it up. What's bimodal mean so we can write it down? Oh yeah, we did talk about bimodal. What's bimodal mean? It's got two modes. Sorry. I was thinking they were talking about something else. That's right. It's got two modes. Did we do a whole lot with it having two modes? Who cares? Alright. What's this symbol? Mu, what's it stand for? The mean. What's this symbol? Sigma. What's it stand for? Standard deviation. What's this symbol? Summation. Outliers, gaps, so on, so on. No symmetric. Remember symmetric? We just talked about it. It looks like this. Looks something like that maybe. Uniform. Uniform looks like this. It's all the same or about the same. Skewed right, and I'm just going to draw the curve on this one. Skewed left, that means it's got a tail out towards the left like that. That's skewed left. Skewed right, it's got a tail going out the other way. These are all the different symbols. We wrote this chart down before. Variance, standard deviation, mean. N stands for how many of them you're dealing with, the sum of the squares, so on, so on, so on. Skip over that, we wrote it down. Remember, these are your two formulas for variance. This formula is for a what? Population. This one's for a sample. Hopefully you got those down somewhere. The only difference, n minus 1 and n. For a population, you use just the whole set. For a sample, you take n minus 1. Standard deviation, all you do to find the standard deviation, once you find the variance, is take the what? Take the square root. Does anybody need those formulas, or should I go on? Go on? Everybody's got them somewhere. We already wrote them down probably 3 or 4 times, right? Use the empirical rule. With the empirical rule, what percent should fall in here? 68%. What percent should fall within 2 standard deviations? 95. And what percent should fall within 3? 99.7. Be able to find quartiles, we just did that, make a box and whisker plot. This, again, is gonna be very important. I don't know that there's a whole lot on this test, but we're gonna use it a lot later in the class. Make sure you know that formula, z-scores. Take the value, whatever value you're dealing with, minus the mean, divided by the standard deviation. So if we had a set of numbers, 2, 3, 3, 4, 5, and we wanted to deal with this 4 right here, we put the 4 right there, subtract off the mean, we'd have to find the mean, find the standard deviation, divide it. That's gonna tell us the z-score. That z-score we're gonna be able to compare to other z-scores. So we could take Dalton's z-score and compare it to Michael's z-score. Even though maybe the two things really don't have anything to do with each other, we could compare them by using their z-scores. You could take we could change all your grades to z-scores, like your English grade, and compare it to your math grade. Even though do the two grades have anything whatsoever to do with each other? No, but we could compare by using the z-scores. You can't take your English grade that's a 85 and your math grade that's a 62 and compare them that way. But we could change each one of those into a z-score and then we could compare. And then you could go to Mr. McKnight and say, look, my z-score in Ebersol's class is a negative 5.2. And it shouldn't be that, because all z-scores should fall within what?
0,
Negative 3 to positive 3. They should fall within
Then what was that?
negative 3 to positive 3 because they should be within certain 3 standard deviations of the mean. What was it that went from 0 up?
It was like something, it can be 0, I think it was the z-score, so it can be 0.
No, z-score can't be 0. It can be. Standard deviation is what you're thinking of.
Yeah.
Standard deviation's always got to be a positive number. It's got to be 0 or higher. If the standard deviation is 0, then what's our graph going to look like? It's going to be just one number where everything fell in that range. But your standard deviation can't be a negative number because that doesn't make sense for something. You're saying the number goes up by this much each time. Well, if it's a negative number, it's not going up. Does that make sense?
Yeah.